from Quantica, a consultancy company which works with system integration, big data architectures, and I'm a engineer and part of innovation team whose goal is to bring innovation into projects with the delivery team. This winter, together with our analytics team, we decided to play with deep learning, and in particular with Fast AI library. You can find the courses online. The guru, Jeremy, explains deep learning techniques to some use case. And we started with image classification. And my experiment, my game, was to build a pizza detector. So an application which, from a photo, would be able to classify the pizza flavor. Next. So now I would like, slice by slice, like if it was a pizza, to show you the solution that I built. First of all, the recipe for this pizza. So a bit of mathematics and statistics. Concepts like loss function and gradient needs this kind of experience. Data mining, of course, to evaluate the model, and a little bit of Python, not too much, to use Fast AI library and to develop the model, and a little bit of HTML and CSS for the front end, you know, and also Docker and cloud. In this case, I deployed the application to Google Kubernetes Engine. Next. So I decided to focus on 15 classes. Choose your favorite flavor of pizza, and we can add more flavors. And these were the more popular and easier to find, so I decided for this. Next, please. So the first challenge was collecting data. Of course, you know that this is the most challenging part. And I tried to start from search engines like Google, Bing, etc. But as you know, after the first results, you get only trash. For example, here you can get, this was a search for pizza e frutti di mare, so seafood pizza. And I don't think this is pizza frutti di mare, this no. Here there is no pizza at all. So you can understand why you get trash. Next, please. So I decided to focus on Instagram photos because pizza is one of the most of the object for which people take most photos, especially on Instagram, and to play with hashtags. So with hashtags, you can generally search for pizza hashtag or pizza with flavor hashtag, as you can see here, and actually you get most of the time the right flavor. Next, please. But there are some challenges also in this case. Customization, photos containing more than a pizza, ambiguity, and fashion. I will explain now. And at the end of the process, I had for each of the 15 classes about 70 and 100 images, which are not too much actually for a deep learning solution, but with data augmentation it can work. Okay. Next, please. So for customization, what do I mean? When you take a pizza and ask to add an ingredient, that is not the actual, the original flavor of the pizza. Okay. For example, this can be pizza with ham, but there is also pepperoni. So it's not actually one of the classes that I was working with, especially the third one on the right. Okay. Next, please. Photos containing more than pizza. I cannot use these photos for learning because in this case the task was image classification task where one photo, one class. Okay, I could have developed a model which can give an output more than a class. So in that case, that would be useful actually. Ambiguity. Okay. Do you know Cracco Margherita? So unless you know that this is Margherita, I wouldn't tell that this is a Margherita at all. Okay, so for this kind of ambiguity, I have to don't consider image. Fashion. What do I mean with fashion? People take photos of pizzas that are beautiful, actually. Okay, so for example, this is home-delivered pizza, almost white, but this is a Margherita, I think. But the model has to be trained on the images that are similar and is clear the flavor. Okay, so for this kind of pizzas, I think that better chance is to add more flavors to the model to handle homemade pizza like the first one, which is different from a pizza in a restaurant, or home-delivered pizza. So, third slice of pizza is building a data bunch. A data bunch in FastAI is an object, a class, containing all the data where the model needs to be trained. Okay? And this is actually the code that I used. So I specify a folder where the images are, and I say how the train set and validation set is divided. In this case, just to go on with the model, I said 20% of the images randomly taken go to the validation set. Okay, and here I also put some transformations that would be used to data augmentation, and here I used ImageNet stats. I'll go into this later, but here I'm using the concept of transfer learning. So I'm using a model trained already on other images, actually on an ImageNet dataset, and take that model, put my images to train on, and add more layers on top of that. So the model just needs to adjust some parameters, and the useful thing here is that the model doesn't start from scratch. It starts from some parameters already calculated, so it's really fast to train. Okay? Thanks. So here, this is a summary of all the classes of the model. The number of classes is 15, 1,100 in the training set, and about 300 on the validation set. So here I use the utility show batch to just take a look of my data bunch. Okay, so here you can see that the images in the data bunch are really different from each other because they have or they don't have context. With context, I mean it's not just the photo of the pizza, but pizza and plates and other stuff around, so that the model can be more general, and also perspective, so the photo of the pizza is taken from different point of views, and also cooking style, so the dimensions of the pizza, the quantity of ingredients, etc. Next, please. Okay, so the transforms that I applied, they are simply a set of transformations. So in this case I used rotation of 45 degrees so that, you know, Instagram photos are not always in one point of view, but you can simulate different angles, and also the brightness, for example the contrast, etc., so that the model can be more general in different situations. And here, one important transformation is cut out, which as parameters as a number of holes that will be added to the images. So take an image, put some black squares, and that would help the model not to overfit. Okay? So let's start training the model. To train the model, I use a neural network with an architecture of ResNet 34, which is one of the most used because it's easy to train, it's fast, it has not too much layers, so it is easy to train. And here the importance of transfer learning. So I'm using a model trained on ImageNet, and from that parameters I'm going to adapt the parameters to pizzas. Because ImageNet is a set of photos of everything, okay? Objects in general, animals, etc. Not pizzas, okay? So I'm using that kind of model which is able to understand I don't know, shapes, different stuffs, and now I want to apply that kind of knowledge on pizzas. Okay? Okay. So under the hood, what does the model do? It uses a loss function, which is the function that you use to understand how it is going. Okay? And a learning rate, so that he is able to move in the direction of the gradient of the loss function more or less, depends on the stage of the model. Okay? And I usually start by using a fit-one cycle, which is a technique which starts by improving the learning rate, and then at the top of the learning rate it starts decreasing, so that the model can be tested with different rates. Okay? And I usually start with 4 epochs, which one epoch is the time taken from the model to see all the images. Okay? And usually I start with the model freezed, so with the parameters computed on ImageNet, and I add on top of that one more layer. Okay? So this is just the instruction that I explained, and in 4 epochs you can see that the train loss and the validation loss decrease. Okay? And the loss function here is a mean square error. Okay? And also you can see that the accuracy in 4 epochs with the freeze model reaches 75%. Okay? So here upper parameters are just the learning rate and the number of epochs. And if you would like the architecture, so ResNet 34. Okay? So to go on with the model, I can say unfreeze. So let's try to change all the previous parameters computed on ImageNet and use the learning rate function, which actually trains while increasing the learning rate, then stops when the loss function goes out of control. Okay? Then I plot and try to find a spot where the loss function is still decreasing, because I have to find a global minimum, okay? And in this case could be 1 in A4, okay? Next. So with that learning rate, as you can see here, I just say to the model, try to train for 2 more epochs, okay? And the model, in this case, reaches 83% of accuracy. So actually, I improved the accuracy of the model. I can go on with the process. Okay, so the same. When I have this kind of curve, I'm guessing that the model is it reached the best accuracy actually, more or less. I tried the same to use this learning rate. Next, please. And as you can see, it's converging on 86%. Okay. Actually, I could have gone further with training because here you see that validation loss is still decreasing. So I'm not overfitting the model. I can go on, but I just stopped here. Okay. Let's try to watch the results, understand actually how the model is going. Most confused is an utility that I can use to print the non-diagonal entries of confusion metrics to understand where the model is going bad. Actually, Parmigiana and Ortolana are the most confused one. Why? Because both contains eggplant, melanzana, okay? But one of them contains other vegetables, okay? So it depends on the ability of the model to spot just one vegetable or all of them, okay? And the second one, more difficult actually, because capricciosa is like prosciutto and funghi with addition of some small ingredients. So if the model cannot spot the ingredients, it can say actually the wrong class. And that also happened to me when I was looking for the images, so it can be understood. Okay, next. So here is the confusion matrix. So on the diagonal, this tells us that the model is going good. Okay, next. And here I highlighted the most confused class, so Parmigiana and Ortolana. As you can see, actual classes on the left and predicted on the bottom. So in this case, this was a Parmigiana, but was predicted Ortolana, and this is the opposite. Okay, so 4 and 3 classes were wrong. Next. Next step, I decided to change the architecture. In this case, I used the ResNet 50. 50 is the number of layers. Okay, so more layers, more features that can be understood from the model. I started the same as before, so 4 epochs with the model freezed. Okay, and here it reaches 78%, which is already good. Okay, next. Then I started to say unfreeze the model and find for 2 more epochs new learning rate, and it reaches 85.9%. The same game. Okay, new learning rate, new cycle, 89%. Next. New confusion matrix. Next. So if you remember, here there was a tree. In this case, okay, images can be taken randomly, so this is not actually correct to say, but I can see that I'm not confusing Parmigiana with Ortolana again. I'm still confusing this one. Okay, so I can guess that the model with more layers can be more smart, but we could not be sure of this. Next, please. Okay, so this is another utility that plots predicted and actual class, the loss, and the probability that the model would have saved that trigger. Okay, I highlighted the objects that the model would have spot to say the correct class. So, for example, here the model says crudo rucola e grana because it sees green stuff which gets confused with rucola, but actually this is a margherita because tomato, mozzarella, and basilico. Okay, and also for this one, okay, this is the model says prosciutto and funghi, but actually it's capricciosa because there are olives here, but maybe the model didn't spot them. Okay, and on the top right corner, that is ortolana. Okay, because there are zucchine, but the model maybe is just looking at eggplant. Okay. Sorry, can you go back? And also here I highlighted 11% probability. So even if the model is saying the wrong class, it gives a low probability. So it's still a good model to me. Okay. Thanks. So let's go and speak to about serving. To use the app, I used Python to develop the server side, and I used Docker to package everything into a container, and Kubernetes engine to host it. Okay. The model can be used to predict just one output, even one photo, instead of the whole dataset. Okay. And I decided to use these thresholds just not to give trash in output. So, for example, filter only results with a probability higher than 40, so that the model is quite sure of the results, and a maximum of 5 results, because the model would give in output all the classes, all of the probabilities, otherwise. Okay? Next, please. So, I wanted to try also a continuous integration delivery pipeline. So from the code repository, I used a build mechanism that would be awakened at a push. It builds the container and deploys the application to Google Kubernetes engine. Okay? So every change that I made on the code is directly in the application. So this is the front end of the application, not so smart actually. I tried to put stuff together to make it work. You can try it if you wish at your next pizza. And I put on the right the ingredients for the pizza just to help, because in some cases there is some ambiguity, as I said. Next, please. An example, so in this case this was frutti di mare, and so the model gives one of the flavor with the probability. In the most ambiguous images you can see more than one class in output. So what can be the next steps for this application? Get more data actually, to understand different kind of features, and get data for made on delivered pizza, as I said, and add also not a pizza class, because it's only learning for pizza. If you take a photo of your face and put to the model, if you're similar to pizza, you can get your score. Okay. Also add more classes or more pizza flavors. And also I would like to get feedback from users, from the application, to say, did the model predict the correct class or not? And then collect more data from the users. Next.
Are you sure?
Yes. So for your next pizza, try to take a photo and use the application. Thank you. Questions time?
Yes, one mine. If you put a pizza with ananas,
that is not a pizza.
Okay, that was the answer I wanted. Perfect. Yeah.
So it could be useful for not a pizza class.
Perfect.
Other questions?
You said that you used the mean square error as a loss because it was the default in the library. But is it possible to change the default and try?
Yes, of course.
And did you try to change the loss and see?
Not actually, no.
Okay.
No.
Question?
Yes.
I can't remember. Did you consider also some kind of equalization of images, like luminance equalization?
it is done automatically by saying normalize ImageNet stats.
Okay.
It was one of the first instructions.
Any other questions? No?
And like, did you use calculator or something like that to find already class labeled images or not?
No. Manual work for every image.
Can you talk about, maybe, I'm sure like someone else did something similar, or?
Actually, when I was already working, okay, so I found a guy that did the same task for American pizza, but American pizza has only 4 flavors, so more or less pepperoni, margherita, and really small data set or with less classes, and I think this is more interesting actually.
When you looked for a pre-trained model, you found this object model, but have you maybe looked for other like food model, classifying like fruits and vegetables, meat, stuff like this to use for this?
Interesting question. Actually, no, because all image classifications tasks with FastAI usually start from the pre-trained model, but otherwise I would have find a model similar to pizzas. So it depends on the objects.
Question concerning Kubernetes. How have you designed the cluster? And how many nodes?
Just the tutorial on the doc. Next. One cluster, one node, one container.
Because it would be interesting to think also about the number of...
Yes, that is actually one interesting point. And in this moment, I think that all of you, if all of you call the model, the server cannot handle that. But yes.
How much time have you spent to actually build just the Kubernetes and all the environment?
The serving part?
Yeah, like the two parts, like amount of time, like 50% or like 50%?
80% the first part, 20% the last, the serving part. Most of the time on taking the images and zoom, look for the ingredients and check everything and put the correct class. Yes.
How much time for this task?
I didn't count it. No. I just say this evening I want to go on with the model, so don't look at the hours.
So what was the idea behind, why did you choose to do this particular...
Because I found it interesting to...
Okay, so it was not like a
No.
client,
No.
just an application to use for something else, you know.
Maybe Domino's Pizza could be interesting in this, but I don't know. Other questions?
Yeah.
How much data could be needed to make the Norta pizza cluster?
Well, I don't think too much. Can be the same quantity of images that are in this moment for a category. Could be good. So about 70, 100 maybe, I think.
Because there is, for example, a hat, a car, so do we maybe so
Something
we don't need the 70
specific
for car, 70 for
I think that every image that doesn't contain a pizza could be good, actually. Because the model is going around on images to find colors, shapes, and etc. that reminds it to a pizza. Okay, so if you put a car, you are telling the model, okay, this is a car. There is no pizza here. Okay.
Any more questions? No.
Yeah.
So, thank you.